5 to the power of x. Okay, that is right, 5 to the power of x plus 5 to the power of minus x equals 2. Okay, that's an interesting exponential equation. Alright, so 5 to the power of x plus, how do we write this? 1 over 5 to the power of x, that's what negative means here, equals 2. Let's get rid of this denominator, multiply on everywhere by 5 to the power of x. That will be 5 to the power of x times 5 to the power of x plus 1 equals 2 times 5 to the power of x. In order to make it clear what we did here, we actually use the common denominator, 1 5 to the power of x. This is the same thing. We increase this to bring it to this denominator, and the same thing here, 5 to the power of x. If we take this out, we'll get 2 as before. Now, in this case, we multiply on both sides by 5 to the power of x and get rid of it. So we have only the part on top, which is 5 to the power of x twice, that means to the power of 2, plus 1 equals 2 times 5 to the power of x. Now let's do a quick substitution. Consider that we can use this notation, 5 to the power of x is actually y. So replace 5 to the power of x as y to the power of 2 plus 1 equals 2y. Let's move this to the other side, and we get y to the power of 2 minus 2y, change the sign when we move this here, plus 1 equals, nothing is left on the right side, is 0. We recognize this, it's a quadratic equation, but we can write this as y minus 1 everything to the power of 2 equals 0. You can verify that by raising this to the power of 2, we get this. And in this case, y can be 1. So the value of y in this case is 1. 1 minus 1 to the power of 2 is 0. Now, y is 1, but we know that actually 5 to the power of x is y, that means is 1. How can we write 1 in this case? We write as 5 to the power of 0. So we have an equality with the same base, 5 and 5 here. So we work only on the exponents, x and 0. So from here we deduct that x equals 0. So that's the result of this problem. Thanks.